Hi friends, welcome. My name is Nilesh. In this video, we are going to see how to create or how to bootstrap a Kubernetes cluster on Microsoft Azure using kubeadm, which is a tool which is used to create or bootstrap Kubernetes clusters. This one is required for my own learning. So if you looked at my earlier video, I shared my experience with Kubernetes Certified Administrator or CKA exam, and currently I am preparing for the other exam, which is provided by Cloud Native Computing Foundation along with Linux Foundation, which is the CKAD, Certified Kubernetes Application Developer. And there is also another exam related to the security, CKS, and I also plan to take that up in future. So for these exams, to practice what is required for creating all the tasks or answering all the tasks, I need a Kubernetes cluster. And that is what I'm going to demonstrate in this video, how to create a 3-node Kubernetes cluster with 1 master and 2 worker nodes on Microsoft Azure. So let's look at quickly what is the requirement for CKAD. I will put this link in the description of the video. This tells us about what is the exam all about and what are the different areas which it tries to gauge the candidate on, like the application design, build, application deployment, observability, maintenance, application environment, configuration and security, and finally the services and networking. So if we go into the curriculum overview, here we can see which version of Kubernetes is currently used for conducting this exam. So in the PDF, we can see that currently the CKAD, CKA and CKS curriculum, these are all based on 1.22 version of the Kubernetes. So I'll be setting up the Kubernetes cluster using this same version. To set this up, I will use my Microsoft MVP Azure subscription, and I will use a PowerShell script which is going to create 3 VMs in Microsoft Azure. So I'll trigger this PowerShell script, and then we look into the details of what the script is doing. So I'm using Windows terminal here, which is my favorite terminal, and currently I am in the repository where I'm storing all these assets related to my CKAD preparation. So I have a folder called cluster setup, and if we look at the contents of that folder, it has a PowerShell script to set up the 3 nodes that are required for setting up the VMs on Azure. So if I list the contents of this directory, we can see that there is a markdown file which describes what are the different steps which are required, and then there is a configuration file, config YAML file for kubeadm, which I'll talk a little bit later, and there is the K8s Azure PowerShell script. So let's go and trigger this or fire this PowerShell script. And while the script is running, I will walk you through the different steps that it's performing. So the script is created using parameters, or you can use this in a parameterized way. It takes the subscription name. This is the Microsoft Azure subscription resource group where those 3 VMs have to be created, and the location. So I have defaulted them to have these names using Microsoft Azure sponsorship as the subscription name, demo kubeadm CKAD as the resource group name, and Southeast Asia, which is Singapore, where I'm currently based, as the location. And then it runs a series of Azure CLI or AZCLI commands, and first thing it checks is if the resource group exists. If it doesn't exist, then it will go ahead and create the resource group. Then it will also create a virtual network using subnet name as my subnet, and then we use that virtual network to create a Ubuntu long-term LTS supported image with a standard DS2v2 image size and containing 10 GB of disk size. So these settings, they are common for all the three virtual machines that we are creating, except for the name. So the master will have kubeadm CKAD master as the name, and then we will have worker 1 and worker 2 as the two workers. So if we go back onto our terminal and see what's happening, we can see that it has checked that the resource group doesn't exist, and it has created the resource group with the name as demo kubeadm CKAD, and it's creating the virtual network now. We can also check this by going into the Azure portal. So if I go into portal.azure.com and I look at the resource groups, we can see what are the different resources which get created once that script is executed. So we are looking at the demo kubeadm CKAD resource group, and when I drill down into the details, we would be able to see all the resources which are part of this resource group here. So far there are no resources created. The virtual machines and the public IPs and the disks associated with that, they are still getting created. So let's go back to the terminal and see how is it progressing. Yeah, so here we can see that the virtual network has been created, and now it's creating the master virtual machine, or the VM that will be the master, where all the control plane and the other components which run on Kubernetes master node will be created. So once these virtual machines are ready, then we would need to set up kubeadm, kubectl, and the kubelet on each of those virtual machines. So we can go back to the documentation of Kubernetes and look at how to install kubeadm and how to bootstrap the cluster with kubeadm. So kubeadm is the utility which I said is used for bootstrapping the Kubernetes cluster. So here we can look at the different steps which are required for installing kubeadm. So let's go on top, and there are some prerequisites which we need to check on each machines before we start installing. On Microsoft Azure, the Ubuntu LTS machine that I provisioned, I did not have to do this, so I've skipped this step. But if you're using some other environment like AWS or GCP, you might want to set this up. In terms of what I had to do, I'll show you each of these steps. So we have to install the runtime, and currently Docker, Containerd, or CRI or Cryo are the container runtime interfaces which are supported. I'll be using Docker in this installation. So we'll be installing kubeadm, kubectl, and Kubelet along with Docker on all those three VMs. So here, these are the steps which are shown, and these are exactly the same commands that we will be running on those VMs once they are provisioned. So let's go back and see if our VMs are provisioned now. So the worker node 1 virtual machine is now getting created. Usually it doesn't take this much amount of time, but as it happens with the live demos, it's taking a bit longer than expected. I might actually just clear some of the time or pause the recording if it takes quite long, and I'll come back once all the three VMs are provisioned. So let's wait for a few seconds and see how it goes. Okay, so we have the master virtual machine created. Worker node 1 is also created, and now it's creating the worker node 2 machine. So by the time that is getting created, we can start setting up the master node. So I will add one more tab here to the Windows terminal, and we will SSH into the master node, or the VM which is supposed to be configured as the master node. Even the shell is taking quite long time to load, so let me open 2 more shell windows or tabs so that those will be ready. Okay, so I'm going to SSH into the master node, and since I'm using the private key or the RSA key, I can use that same private key to log in into the master node. This was the key I provided when I provisioned the 3 virtual machines, or 3 machines on Microsoft Azure. So when I do SSH, I can pass the parameters with the input file and the name of the host. So let's go and connect to the master here. So CKAD, kubeadm CKAD master, and once I pass the fully qualified name, it will ask me if I want to add this to my known host, and once I've said yes, I will be connected to the master. So the first thing I will do is update some of the settings on the profile, and I will use the bash profile. So bash rc. I will use VI editor to make some changes so that it's easier for us to work with this particular machine. So let me add a alias here just to clear the screen, which is clear, and I will also add a alias for kubectl, which we'll be using later. So alias, usually we alias k as kubectl, and for other shortcuts I will also create a couple of aliases here. Kget or kg for kget, and same way to get the nodes and the pods, we can put kget pods as kg, short form for pods, po, and the nodes as kg, and no for nodes. And just close this. And save the file, and then let me just reload it. So source it again, .bash rc. So if our profile is set correctly, if I type cls here, I should get the clear screen. So that means the profile has been set now. Now let's go and install the required components for setting up the kubectl, kubeadm, and the kubelet. So for this, I have a markdown file, cluster setup.md, in my repository. I will again share the link to this repository in the description below. This is on GitHub, so you can follow this along. So the first thing we do is on the master node. You can see here that I'm connected to as a user on the kube master. We will run the apt update command to update any of the binaries or any of the utilities. Once we have the updated version of all the packages, let's go and install Docker. So this we can install using sudo apt install docker.io, and we give -yes as the prompt for any of the confirmation that would come as part of the installation. The next thing we would do once the Docker is installed is to set it up as a daemon, so that even if the VM is restarted, we want the Docker also to restart. So it's almost done. Okay, so we have the Docker installed now. Let's go and set this as a daemon. So for that, we will use the systemctl utility and enable Docker as the daemon. Next thing we have to do is to get the GPG keys for installing kubeadm. So for this we use the curl command and we get the keys, and once we have the keys we add the repository for Kubernetes for our package manager. So once this is added, next thing we do is to add the or to install the kubeadm. Now the thing with kubeadm and kubectl installation is the current version of Kubernetes is 1.23 and I want to set up a cluster which is 1.22 or 1.22. We can verify this by running sudo apt then list, and let's search for kubeadm. So you can see that the current version is 1.23. So if I run the normal command, which is sudo apt install kubeadm, it will install the 1.23 version of kubeadm, whereas and same thing for kubectl and the kubelet. But I want the earlier version, and we can look for all the earlier versions using -a switch here, and that will show us all the earlier versions of this package kubeadm. So here we can see 1.17, 1.19, 1.18 version, and all the previous versions of this package. So I am interested in getting 1.22.0 version, and to get that I will have to specify at the time of installation I want to use specifically that 1.22 version. So let's go and run that command. Here I will run sudo apt install kubeadm. I'm giving 1.22 version for all three, kubeadm, kubectl and kubelet, and yes as the flag. So any prompts, if they are asked during the installation, it will be accepted as yes or the defaults. Once the kubeadm and the kubectl, kubelet, these are set, then we can go and run the kubeadm init command. Now by default, if we don't provide any overrides or parameters, we can initialize the kubeadm with the default values. Let's try to do that first before we go and start customizing it or overriding the default. So here we can see that the kubectl, kubeadm and the kubelet, all these three are set to 1.22 version. So let me go and run the kubeadm init command here without any overrides. So this will try to install or set the version as 1.22. It will do some pre-checks and it will try to pull the required images, and it will set up the Kubernetes cluster for us. So kubeadm init is used on the master node to set up all the control plane components like the etcd and the controllers. So you can see here that it's creating folders for storing the certificates. It will generate the keys, the certificates. It will do all the signing for the DNS names and all that prerequisite which is required to bootstrap the cluster. and then it's waiting for the kubelet, and here it might take about 4 minutes. Usually it takes lesser than that, and we will see some sort of error here because with version 1.22 we need to do some pre-configurations. So if we go back into the documentation of Kubernetes, we will find that this is documented, or this is highlighted in the document, saying we have to configure things like the cgroup driver. There is also the configuration which needs to be done for the container runtime and the kubelet. So for doing this, you can go through the link, but I already have done this and I have it in my repository. So let me pull that repository configuration again, and let me do the first step, which is to provide a configuration for the kubeadm. And the configuration that we are providing is we create a YAML file called kubeadm config.yaml, and we are providing a cluster configuration of type cluster configuration here for the version 1.22, and the kubelet configuration that we specify here is the cgroup driver should be systemd. So I'll copy all this content from this file and go back onto the master node, create this file, and override our kubeadm init command. So let's stop this, check what it is trying to do with the kubelet. It won't work. So before I run that configuration, let me reset the kubeadm. So what the reset command tries to do is it will reverse the changes and it will try to go back to the previous state. So the reset command, and I will pass the force flag. So this one will take the system back to the previous state where we didn't have anything set up via the kubeadm. Now I will create that file again, or I will create that file here on the master node, which is kubeadm config.yaml, and I will paste the contents what I copied from the Visual Studio Code, and let me save this. And then let's verify once that the content has been copied correctly. So cat kubeadm looks like there is some problem. So let me remove this file, rmrf kubeadm. And let's do it again. So vi kubeadm config.yaml, copy the contents and then save the file. Okay, now let's go and read the contents once again. Cat kubeadm this time it's okay. So now let's try to run the same command again, but with the override. So the override that we need to provide the kubeadm init command is to use this config file, kubeadm config, and the command that we will run is to say use the config. So this is the command which we will run. So the command is sudo kubeadm init, and we are passing the config kubeadm config.yaml. So let's see what happens when we use this. It is again going to run that same set of pre-flight checks to see that we are compliant with what are the prerequisites for setting up the Kubernetes cluster. And it's come to the same state again, where it's waiting for the kubelet to boot up on the control plane and start the static pods. So here again we will face a problem, and this is also documented in the prerequisites. That, let me go back to the documentation. So you can see that we have to configure the cgroup driver here, and it's mentioned clearly that it has to match the container runtime, which is in our case Docker here, and the kubelet, the cgroup drivers, it has to be the same. So we have overwritten, or we have configured the kubelet to use the systemd driver, and now we have to do the similar configuration for Docker to override the default configuration. So let me show you that setting which needs to be done for the Docker, or the Docker daemon. So we need to copy these 5-6 lines of code. Go back to our master node, and let's stop that kubenet process, because again we can see that still the kubelet is not up and it's refusing the connection. So let's stop this, and let's again revert the process, or reset the kubeadm init process, so that we are again on the same stage before we started the kubenet. So I'll reset the kubeadm, which will revert whatever it was trying to do, and then we override this configuration for the Docker daemon. So we are setting the cgroup driver as systemd again, which is the same as what we have set for the kubelet. And once this is done, now our kubelet and the Docker daemon both have systemd as the cgroup driver. Then we can go and run our kubeadm init command. So hopefully now with these two changes, it should be able to initialize the master node. But before we do that, we have to do one small change, which is to reload the Docker daemon, because we made that change, or the configuration change. So let's go back on the master node, and we reload the daemon, and we also restart the daemon. So the Docker daemon has been restarted. Now we can go and run again the kubeadm init command along with the override that we had specified earlier. So we run kubeadm init with the config file as kubeadm config.yaml, and now we should have the kubelet running, and we should see that our control plane components are all healthy, and we are able to initialize our cluster. Then we also need to copy this kubeconfig file so that we can run the kubectl commands. So I will do this step, but before that, in order to join our worker nodes, we also need this join command to be copied. So let me first copy this and store it. Okay, and before I run the join command, or before I go and update the worker nodes, I need to copy that config file, the kubeconfig. So let me create the .kube directory under my user. Then we copy the file from etc kubernetes admin.conf location to this .kube folder, and then we also change the ownership, because by default it is under the ownership of kubeadm user or sudo. We change it to the current user. So with that, we should be able to now run the basic kubectl commands. So let's see what is the state of our cluster. So kubectl, if we do get nodes, we should see one node, which is the master node, and we can see the name is kubemaster. The role is control plane master. It's created just about 2 minutes ago, and the version is 1.22, which is what we downloaded and created with a specific version. The current status is not ready. So let's describe this node and see why the node is not ready. So I will use the alias k and then describe node and the name of the node kubemaster. So we can see here it shows the description, and somewhere in the conditions we can see that ready is not ready, kubelet not ready, and container runtime network is not ready. So when we configure the cluster using kubeadm, we need to provide the network plugin, and there are different plugins available or supported by Kubernetes. I'll be using VNet as one of the plugin which is available. So let's switch back to the Visual Studio Code and get the command to install the pod network using the VNet. Let me just scroll. For some reason, again, scrolling through the mouse is behaving weird during recording of the videos. So I will take this command and let's run this. So we are going to apply a file or a manifest file from cloud.view.works. CKAD version, we are providing our current version 1.22, and we can see that it created a service account, cluster role binding, RBAC, and VNet daemon set is also created. So let's get all the pods and see if the networking pod is running. It's part of the kube system. So let's run get all pods across all namespaces, and we can see that VNet pod under kube system is running just about 27 seconds ago. So now if we go and get the nodes, we should see a change in the status of our master node. Let's run kubectl get nodes and we can see that the kube master is now in ready state. With that, we have our master set up. Now let's go and set the worker nodes. So the process is similar in terms of the kubelet configuration and kubeadm configuration, but in terms of initializing the kubeadm, that is something which we don't do for the worker nodes, because we only initialize. In this case, since I want to have only one master, I need to run the kubeadm init command only on the master node, and then for the workers I need to run the join command. So let's start by setting up first the prerequisites for kubeadm, and then once the kubeadm is set up, we will go and run the join command. So the process is exactly same that we ran on the master node. We run the apt update command to get the updated version of the packages to start with. So I'm now connected to the worker node and I'm running all the commands on the worker node. So let's go and install Docker. And once the Docker is installed, we can also set it up as the daemon. So using systemctl, enable that. So this helps to run Docker as a daemon. Even if this VM, if we stop it and restart it, the daemon will be started again when the VM is restarted. Then we go and get the GPG key and add the repository. So once the repository is added, then we will go and install the specific versions of kubeadm, kubectl and kubelet on the first worker node. And once that is done, then we go and update the config for the Docker daemon. Now the setting which we did on the master node for the override of kubeadm, the config file, we don't need to do that on the worker nodes. It's only the configuration for Docker daemon that is required, or the override for Docker daemon is required on both the workers. So the process would be slightly quicker here in terms of updating this and setting up the Docker daemon. So let's go reload, and the last step before we join the node is to restart the daemon. Now with that, we have the settings or the override done for the Docker or the container runtime here. So the last part here is to run the join command. So before I run the join command, let's go back on the master node and find out what are the nodes that we have. And we should have only the master node shown here. I will also set a watch here so that we can see the changes in when the node gets added. Now let's go back onto the worker node terminal. Let's clear this out and I will run the join command here. So this join command will join this particular worker 1 to our master node or to the Kubernetes cluster. So let's go back here and we should see some changes happening as the worker node gets ready. So you can see here that the kube worker node has been added, and it's currently not ready because it still needs to install some of the components like the kube proxy and the kubelet. Kubelet is already installed, but the kube proxy has to be ready, and some of the other components which are required for communication between the worker node and the master node. And then we can see that after about 20 seconds the worker node is ready now. So let me stop this watch that we were having, and let me just run the command to get all the nodes without the watch. So now we have two nodes, the master with control plane and the worker which is ready. Let's go and set up the worker 2 as well. In the video I will fast forward this, but I will follow the same steps on worker 2. So SSH, and we are going to connect to worker 2 here and run the same set of steps that we ran on worker 1. Let's try. And now we can see that all the three nodes are ready. So we followed exactly the same steps that we did on worker 1 on worker 2 as well, and both the worker nodes are ready. Now to test that the cluster is in good state and everything has been set correctly, let me go and create a small deployment or a test deployment here, and we will see that it works fine. So let's say create deployment, or we can also say create deploy. Name of the deployment is let's create a nginx here, nginx deploy, and the image that it will use is Nginx, and let's also create 5 replicas of it. So the deployment has been created. Let's go and get all the pods, and let's use output as the wide output. So we can see that the 5 pods are getting created here, and it is distributed across the 2 worker nodes that we have. 3 pods are getting created on worker node 1 and 2 pods are getting created on worker node 2. We can also describe the deployment. So we can say Nginx deploy and see what we get. So there is a typo in the name of the deployment name. There is N missing. So let's correct that. And if we describe, we can see that everything is fine here. So that's all I had to show in this video. It's a slightly longer one, but I hope you got what I was trying to do here. So to summarize what we did, we provisioned 3 VMs, Ubuntu based VMs on Microsoft Azure. Then we use kubeadm to set up the control plane, and we have overridden some of the default settings which is required for a 1.22 version of Kubernetes to have the same settings between the kubelet and the container runtime, which is Docker here. So we have used systemd as the process which manages both of these, and then we set up the worker nodes and we joined the 2 worker nodes. With that, I come to the end of this video. I hope you find it useful. If you find this video useful, please hit the like button, subscribe to my channel, and share it with your friends and family over the social media or other channels. Thank you. Thanks for watching this video.